Hello all, welcome to the video series Learn Web Automation using Playwright for .NET. In this video, we will try to understand what Playwright is and write our first lines of automation using Playwright and .NET. What is Playwright? It is an end-to-end automation framework for testing modern web applications. Why Playwright? Playwright supports all modern rendering engines including Chromium, WebKit, and Firefox. It is multi-platform, enabling testing on Windows, Linux, or macOS. Playwright API can be used with TypeScript, JavaScript, Python, .NET, or Java. It is resilient, with features such as auto-wait, which eliminate flaky tests. It also has powerful tooling, such as Code Generator, DOM Inspector, and Trace Viewer. Let us set up our dev box to start creating our automation. First step, install Visual Studio Code. Go to code.visualstudio.com. Choose the appropriate operating system and architecture. Download and install Visual Studio Code. I have already installed Visual Studio Code on my machine. Go to Extensions tab and install C# Dev Kit. Next, install .NET Runtime. Go to .NET.microsoft.com and download the latest .NET Runtime, which is .NET 8, which is in long-term support. Download and install. Make sure that .NET 8 is installed properly by going to Visual Studio Code, opening up a terminal window and running the .NET version command. Make sure it returns 8.0. Let's start writing our automation. Go to File and open a folder. I already created a folder called Playwright where I put my automation. Select the folder. Go to Terminal and create a new MS Test project. To create a new MS Test project, I'll run the command .NET new MS Test -n and give it a name. Here I'm choosing the MS Test project. You can also choose XUnit or NUnit test frameworks. Once this command executes successfully, you will see a Playwright lesson project has been created. There's the unittest.cs. This is the standard MS Test syntax or template. We already installed C# Dev Kit in Visual Studio Code. So if you were to collapse this and go down, you will see the Solution Explorer. We will use the Solution Explorer to author our tests. Let us install the Playwright NuGet package. Go to the terminal and go to the folder where your project file is created. Here, run the command .NET add package Microsoft Playwright MS Test. Once the NuGet package is installed, it's time to install the browsers that we wish to run our automation against. Go back to the terminal, go to the folder where your project file is present and run the command .NET build. This will build the project and copy the artifacts to the output folder. In this output folder, there is an artifact called playwright.ps1. Let's execute that PowerShell script with the install command. This will install all the browsers that we need for our automation, including Chromium, WebKit, and Firefox. Once this installation is complete, we are ready to write our first test using Playwright and .NET. Let us do something simple for our first test. Let's just navigate to playwright.dev. verify the title of the page, click on Get Started, and ensure that we ended up on the right page. Let's see how we can do this. Let's start writing our first test. Please note, I renamed the test file, I changed the name of the class, and I changed the name of the test method. The first step in writing our automation is to initialize the Playwright engine. In order to do that, go to globalUsings.cs and add a using directive to Microsoft.Playwright namespace. Back in our test class, let's start by initializing the Playwright engine by calling the playwright.createAsync method. This async method returns an instance of Playwright. And given this is an async method, we need to await that call. Let's start by changing the return type to task and adding the async keyword. Let's await the call to create async. This step will initialize the Playwright engine and it will return an instance of the Playwright engine. Step is to launch the browser. As mentioned before, Playwright supports several different rendering engines, including Chromium, Firefox, and WebKit. For this test, let's launch Chromium. I will use the Playwright engine instance we got in the previous line and select the Chromium browser and use the method launchAsync to launch the browser. This is also an async method returning a browser instance. Next step is to create the browser context. A browser context is an isolated clean state environment. Each browser context has its own local storage, session storage, and cookies. Browser contexts are fast and cheap to create. Each test should get its own browser context. Running each test in its own browser context helps prevent failure carryover. It makes the test easy to debug, and we do not need to think about ordering when running tests in parallel. Let us create the browser context. Use the instance of Chromium browser and create a new context. This returns an instance of the browser context. Next, let's create a new page instance associated with a browser context. Creating a new page instance allows for actions and interactions to be performed on that specific page while maintaining separation from other pages in the same browser context. To create a new page instance, we use the browser context new page async method. Now that we have a page instance, we can go ahead and start performing the actions and interactions on this page. Next, let's write code to go to the Playwright website. Once there, we'll also validate the page title is accurate. I have the expected title here. In order to navigate, let us use the goToAsync method on the page class. This is an asynchronous method, so let's await. Once this is complete, let's validate the title. I'm going to use the MS Test Framework's asserts class. We're going to use the r equal method, and I'm going to put the expected title here. Now we need to get what is the page title. In order to read the page title, we can use the page dot title async method. This is also an asynchronous method, so let's await. Now that our code is ready, let's execute. Open a new terminal. Run the command .NET build. Once the build is complete, run the command .NET test. This will execute our tests. Note that our test execution is completed successfully. While the test completed successfully, you might have noticed that we did not see a browser window while the tests were executing. That is because, by default, Playwright launches its browser in headless mode. What is headless mode? In headless mode, the browser runs in the background, so there is no visible user interface. Since headless browsers don't render the UI, they typically use fewer system resources compared to browsers with a visible interface. This is important when running automated tests, in large test suites or on servers where resource utilization needs to be optimized. UI rendering can take time, and by running in headless mode, we can often achieve faster execution of our automated tests. Most browsers implement headless mode. Let's see, in case we want to debug some failures, how we can disable headless mode. We can disable headless mode by configuring the headless property on the browser. Go to the place where we created a browser. In the launch async method, we can pass in an additional parameter called the browser launch type options. Let's specify a new browser launch type options and set the property headless equals to false. Let's also set up the slow-mo property. This delays the execution of the Playwright operations by whatever time we specify. This makes it easier for us to see the actions being performed. Let's provide 1000 milliseconds. This will disable the headless mode. Let's save the file. Go back to the terminal window and run .NET test command. This will build and re-execute the tests. This time you see the browser has opened and the test is complete. Now that we executed our first test, let's do some refactoring. Every test needs to initialize the Playwright engine, create a browser context, and a page instance. Instead of doing that in each test method, we can take all these 4 lines of code and move it as part of the test initialize method. Let us move the initialization code to the test initialize method. In the MS test world, any function which is decorated with the test initialize attribute gets executed before each test. Let's start by defining a method called setup. Let us decorate it with the attribute test initialize. Copy the 4 lines of code to the test initialize method. This will bootstrap each and every single test with the initialization code. Writing our own test initialization code, we can use a set of base classes provided by the Playwright team. In order to use these base classes, I will start by going to globalUsings.cs and adding a new using directive. I will add a using directive to Microsoft.playwright.mstest namespace. Once this is added, go back to the test class and inherit the test class from an abstract class pageTest. Let us see what this pageTest provides us with. It provides us with an initialization code which sets up a new page in the test_initialize method. It also defines a publicly accessible iPage instance. Please note, pageTest class derives from the contextTest class. This contextTest class has additional logic to set up browser context. So now that we have a new page instance provided by the base class, let's go back to the test class and delete the test_initialize method. Once we delete the test_initialize method, let's update our test method to use the this.page member defined in the base class. We will also update our assertion, and we are now ready to run the test case. Before we execute the test case, let us make one more change. Here you can see we are using the MS Test Framework's assert.requal method to do the comparisons between the expected title and the page title. Playwright provides us with a set of assertions that we could use in our tests. Playwright provides a function called expect, which will return an assertion helper, which can be used to assert and wait until the expected condition is met. In order to start using the assertions, let's start by calling the expect method. Pass in the UI element that we are trying to validate. In this case, we are trying to validate the title of the page. So we pass in the page instance, and then we can execute one of the assertions defined for the page element. Here we have the toHaveTitle async and the toHaveURL async methods. Other assertions are provided for other UI elements. So let's start by using the toHaveTitle async, passing in the expected title, awaiting this entire method, and then let's remove the old assert.requal statement. Now our test is ready. Let's go ahead and execute. Open up a new terminal and run the command .NET test. All the tests have passed, and we have achieved the same thing that we've done before with very less number of lines of code. Let's end this video here and pick it back up in the next session. In the next session, we will explore how to find and take actions on the UX elements of the page. If you like this content, please subscribe and leave a like. Thank you.